Here's a quick little video to show you a project I've been working on lately. This is a control panel that will be used in a effigy at a regional Burning Man event in a couple weeks. This control panel will be in a spaceship-themed effigy, and the idea is these buttons can trigger sounds and lights. So we have little sound effects on most of these buttons. This control panel has an awful lot of buttons on it here, and so up on the top of the control panel we have these little speakers. These little speakers are what's making the sound as we're pushing the buttons, and the speakers are connected. You can see kind of back here where the power comes in on these slots. This is where the speakers all connect here. And these two data ports are RS-45. This one sends DMX lighting controls, which we'll see in a moment, and this one here controls a motor, which we'll also see in a moment here. The entire thing is run by Arduino code, and we've got a USB port plugged in here. This will run from batteries at the event. We're powering it off a 24-volt power supply here for testing, and then the lights and the motor run off their own battery. So over here we have this. This is the motor system here with this offset weight that Dave made. This thing's really great. And here we have a standard 27-channel DMX lighting controller and just a few LEDs. These will obviously be long strips installed on the art for the event. 12-volt battery running the lights. So if we come over here, some of these buttons here will control some of the lights, so we can change when events happen with the control panel. These lights can change. I believe this button here was programmed for 3 different, so we get 2 different sounds, so we can control things. Just recently, some code was added to do timed effects. This one here will do a red alert mode, I believe. And as we're in red alert mode, we see the timed effect is triggering the lights as well as the sound. I believe we have a 7 or 8 second delay, then we'll hear the red alert go again. And as I recall, button 81 has a stand down from red alert. So, so anyway, this is lots of fun, silly stuff. But so if we come over here, these little sound effects from these little 2-inch speakers actually sound not too bad for cheap little 2-inch speakers. But this motor here is meant to really add a little oomph to some of the effects. So button number 4, I believe we have an explosion sound. And when we hit the button, we'll hear the explosion and it'll turn on this motor. So let's see if I can get them both in the camera. I don't know if you heard the rumble, but we can see it move across, right around on the table. Shakes this whole area. So the plan is that this, so some of these other ones here have some lesser, we can control the speed of the motor. There's one that's pretty slow. Here's a faster one. So we can turn the motor on for different amounts of time, and we can turn it on at different speeds to really get some different effects and add a little bit of vibration in the in the whole effigy structure to really reinforce the sound effects. So let's take a quick peek at the insides of this thing. See how it's all wired up in here. If I can awkwardly hold the camera while I lift this thing up, and then let's see if I can hold this, and I think it's a book or a weight put inside of it, so we have a book there to keep this thing from tipping over. So inside, this little guy here is what's controlling everything. This is a Teensy 3.2, and it's got the audio board playing the audio effects. This little 32 gigabyte card holds all the sounds. And here are the 2 control channels for the motor and for the DMX. Or this one is the DMX lighting, and this one here is the motor, and the little RS-45 chips to transmit. So all of the lights are controlled by this purple wire. This wire right here sends out messages, and this one here, all the buttons and the knobs are read on this one wire. So to do that, these little boards here with the transistors are controlling the lights. This thing is a ancient piece of equipment, and so these transistors are needed to get the voltage up to 24 volts to turn on the lamps inside the switches. And we've got one over there and another one here. And where's the third one? Is way over here. I only built three of these because they take quite a lot of work to solder all those transistors on there. So only about half of the lights are able to come on. So the way this works is the main controller sends out messages saying which light it wants to turn on. This one here controls the first 32, and if it gets a message for light 33 or higher, it subtracts 32 and sends it to the next board down there. And then this board here, if it gets a message for light more than 32, it sends it to the other board in the other corner. And so the one wire can send out messages for all the lights. Similarly, the buttons work the same way. We see a teensy down in there. These were, I know that some people will probably second guess using teensies and will suggest that this should have been done with shift registers or port expanders, but I happen to have quite a few of these teensies sitting in my junk bin, so they got used, and it worked out really well. So these teensies read all these buttons and just transmit when buttons occur. They do the debouncing and send the messages down the wire, and each one increments the number by 50 some and sends it to the next. We have a little power supply here to create the 5 volts from the 24. A bunch of other stuff that didn't get connected. Here we have one more little teensy that's reading these 10 knobs in this region. The code at this point is in the controller. We have this awesome lever knob here on the front, and the Arduino code can receive the data about the position of these knobs, and there isn't yet a whole lot of code doing anything with that information. So the controller, all the wires come down here. Here are the two data lines for the control of the vibration motor and the lights, USB upgrade, power, and a whole lot of ancient technology in this thing that all had to be cut away. All these huge wire bundles. So this is what's inside the thing. I know I've posted a couple pictures and people have reacted strongly to the rat's nest of wires in here, and I'm sure there'll be no shortage of that in this. This entire project was quite a bit of work, and a lot of this was done in this kind of haphazard way, really to reduce the amount of time needed to do this. I spent probably about 3 or 4 all-nighters on hooking up all these wires. It went pretty quickly because it's not done really neatly. So I'm going to close this back up here now that I took the book out to keep it from falling. And just give these a couple more presses here. We can go into red alert mode. I really like the red alert mode. Or we can cancel that. And we can, these buttons here control these 3 lights in different combinations. We've got the motor, of course, turns on there. As I recall, this button here was programmed for 3 different levels there. The little speakers making the sounds back here. And that is pretty much how this thing works. So here's all of it on one shot. And we have about 2 weeks left to go towards the event, and I'm going to hand this off to some other people for a couple weeks who will probably do some more work with the Arduino side of this and recording more sounds. And then I'll probably work on it again for a couple more days right before the event. And hopefully everyone will have a whole lot of fun. As you would expect from any kind of a project for a Burning Man type of thing, there's going to be probably some pretty silly sounds. I think these 2 knobs, these 2 buttons had, let's try these.
You really know how to push my buttons.
Let's see what this one was also a funny.
Talk nerdy to me.
So hopefully Rachel and others will record some more sounds. I know that Jimmy was planning to do some planning to do some other fun kinds of things with this. So fun project, and and I am really glad that my part of this is coming to a conclusion, because it's been quite a bit of work. So hopefully this will probably be the last time that I have it all together on one table. So hopefully this little video captured how this thing was built for future reference, and here it is.